In section 8.1, we reviewed U substitution and also a bunch of algebra tricks, basically using a lot of algebra and pre-calc to kind of finagle our way around integrals. But now it's time to start learning some new techniques. And the first one we're going to learn is a doozy. It's integration by parts. And by doozy, I mean this is one that we use a lot. It's probably the second most used technique after the substitution rule. So the substitution rule, I don't know if you remember learning it this way, but the substitution rule is actually the integration equivalent of the chain rule. They're equivalent to each other in reverse, right? So the chain rule in reverse is the substitution rule and vice versa, right? They go together. So now you're about to learn that the product rule in differentiation and integration by parts are the same thing but in reverse, right? They're related to each other. Now let me show you what I mean by that. So we remember from Calc 1 that the derivative with respect to x of u times v is u prime v plus uv prime. Sometimes they do it with f and g, but it's the same idea. We're going to use u and v because usually they're smaller functions nested inside a larger one, much like with u substitution. Okay, so now imagine for a moment that we integrate both sides of this, right? If you integrate both sides of this with respect to x, oops, and over here too, on the left you would have u times v, no problem. On the right, you would have, let me see here, the integral of u prime v plus the integral of uv prime. So this piece right here. So what would this be? Well, that would be the integral of v, and then u prime is du dx times, and then of course dx, because there's a dx there. Let me rewrite this way. Right? In other words, I'm just taking the u prime and I'm writing it like that. Okay, well, why am I doing that? Well, give me a minute. Let me do the other one. Okay, so then this one would be the integral of, and then it would have a u, and then v prime of x. Let me rewrite that with Leibniz notation. That's dv dx, and then there's a dx here. Oh, and then there's a big addition. Okay, how in the world, what's going on? Well, look at what happens. The dx's cancel. And so you're left with the integral of v du plus the integral of u, and here the dx's cancel, dv. Interesting, huh? So uv, what was over here on the other side, uv is equal to those pieces. And then we just kind of rearrange them. Here's the uv right here. And what they do is they put u and v together with the green one, v du. That's this one. So minus, because you just subtract this to the other side. So minus the integral of v du. And then that's equal to the orange one. That's the only one that's left over. So if you minus this one from both sides, then you're left with this one over here is right here. And that's how we write it. That's what it is right down here. The integral of uv, or excuse me, u dv is equal to uv minus the integral of v du. Cool, huh? So that's integration by parts. It's basically the product rule, but then you integrated both sides of the product rule and then you rearrange it, right? It's just kind of rearranging the order into an order that we can actually use for when we do this. Now, based on what we know for how derivatives and integrals work, there's a little handy way of remembering how to do which one. And the answer, because if there's two things multiplied, how do you know which one's u and how do you know which one's v? And the answer is right here. For integration by parts, the key acronym, it's a mnemonic, if you want to know. It's a way to remember it, right? It's a memory device. Mnemonic. It's LIPET, L-I-P-E-T, right? Logarithms, inverse trig, polynomials, exponentials, trig. So the order is your first choice would be a logarithm, your next choice would be an inverse trig, your next choice would be, right, the last choice you would make. So this is first, this is top, right? That would be the one you try to go for first. If you can't have a log, then you go for inverse trig. If you can't have an inverse trig, you go poly, right? If you can't have poly, you go exponential, and your last choice of all is a trigonometric function. All right, so it doesn't quite mean anything to you at this point because you haven't done an example of it. So let's do an example and see how it goes. Okay, I'm going to leave that right there so we can kind of remember how to do this just for at least a minute. Okay, so we have two functions that are multiplied. If you look, you have an x and you have a sine of 2x. So what you want to do is you want to break it down. I'm actually going to write this down. Step 1, you want to make a little table. And the table goes u, du, dv, and v. And this is where Lipit really matters, right here, because you've got to choose u. It says it's your choice of u, right there. So, u. You would either pick a logarithm. I don't have a logarithm function. Inverse trig. I don't have an inverse trig function. Polynomial. I have a polynomial. That's a polynomial right there. It's x to the 1 power. So my choice for u is x. And that means that dv, right, because what this is, it's the integral of u dv. So that means that the rest of this stuff is dv, right here. Oh, I should have done it with orange. I'm sorry. I'm trying to keep my u color coding consistent right here. So that's a polynomial. That's u, right? Okay, so u is x. dv is everything else. So it's sine of 2x dx. The dv's and the du's are going to have a dx in them. That's how they're going to work. Okay, so now you've got to find the other parts, right? So I'm really doing multiple steps, right? Step 1, made table. Step 2, oh, I guess I'll put it here. Step 2, decide on u. Based on Lipit. There we go. I'll just leave it like that. Okay. Then what did I do? Well, I decided u, then I decided dv. So I guess step 3. Decide on dv. Now step 4, I'm actually going to find u and v, or find du and v. All right, so actually, here, I take that back. I'm actually going to add those in right here. The order's a little weird here, but I'm going to decide on u and find dv, or du, find du right here. And I'm going to decide on dv and find v. Oh my goodness, if I could spell. Find v. All right, what does that mean? Okay, if this is u, this is the derivative of u. And the derivative of x is 1 with respect to x. So it's 1 dx. So I find du and u, right? So figure out your u and then find du. Sorry, that's 2 words. Technically, du isn't a word. It's a differential, but you know, what you going to do? Find du. There we go. That's a little clearer. Now, v, right? I decide on my dv and then I find v to go with it. So I integrate this. The integral of sine would be negative, right? It would be a cosine of 2x, but then it has to be a half in order to make up for the fact that there's a 2 inside there, right? Think about it this way. You need to be able to find the derivative of v and get dv. So if I just left it as cosine, cosine's no good because the derivative of cosine is negative sine. So I need negative cosine. But again, there's a 2x in here, and the derivative of negative cosine of 2x would be sine of 2x times 2. But I don't have a 2, so I need a negative 1/2. It's sort of like you're doing a little mini u substitution in your head. All right, so that's done. Now we check it all over. Check table over. We won't write all the steps all the time. This is just, for our own benefit. So we've got our table right here. Step 1, we made the table. Step 2, we decided how we were going to fill out the left-hand column of the table. Step 3, we're going to decide how we were going to fill out the right-hand column of the table. Step 4, we kind of look it all over, make sure it makes sense. Can I take the derivative of this and get that, and so on. And step 5, use the by parts formula. Okay, so what does that mean? Well, it means I'm going to rewrite my integral. So my integral was x sine of 2x dx. I will now write that. So that was u dv. And you can see the by parts formula. It says rewrite u dv as equal to uv minus the integral of v du. It says it right there. So I'm going to write u and then v minus the integral of v du. Luckily for me, I have them all filled out in a table. So all I have to do is substitute, right? So this is u, which is x, v, which was negative 1/2 cosine of 2x, and those are multiplied, right? So there's u, there's v, minus integral, v again, so that's negative 1/2 cosine of 2x, du, which was times 1 dx. There's step 5. And step 6 is to actually integrate. Okay, let's do it. So I'm going to rewrite this. This is no good to me like it is. All right, so this is negative 1/2 x cosine of 2x. Now you'll notice there's no more integral on that part. We're done, right? We did the uv part. That's fine. Over here, minus a minus makes plus 1/2 because it's a constant. Integral of cosine of 2x dx. Well, again, it's just like that dv that I just did up here. The integral of cosine is sine, but there's a 2 there, right? So it would be negative 1/2 x cosine of 2x right here, plus a half. And then for this piece right here, the integral of cosine is sine. But if I leave it as sine of 2x, the derivative of sine of 2x is cosine of 2x times 2, right? Because of chain rule. I don't want a 2, so I need to multiply by another 1/2. Essentially, what we're doing is a u substitution. But we're past the point of needing to show every little tiny u sub that we use, especially for something as basic as 2x, right? Because our u is 2x. That's kind of ridiculous to show u sub all the time for that. So this is negative 1/2 x cosine of 2x plus 1/4 sine of 2x plus c. There you go. You've done your first integration by parts. And again, we don't show the steps over here all the time. You do always show this table, completely filled out and lovely. That has to always be shown. And then you kind of show all this work. But for this problem, I wrote all the steps out in words so that you could follow along the process.